All right. Hey, that's the most uncertain thing we're going to do today, right there. Well, we're going to do one thing that's even more uncertain. We're going to try and run a live demo, which is always dangerous in a conference. So 30 years ago, on one of my very first professional jobs, I was the marketing manager for a semiconductor product line. And one of the most important performance areas for me was to forecast demand, future demand. And so we had a very sophisticated process to do that. We talked to all of our customers because who would know better about what the customer needs were than the customers themselves. So we went and talked with all of them, built detailed bottoms-up model, compared that to historical trend lines, used our own judgment, and the results were terrible. And I was always in trouble because the manufacturing guys hated me because, of course, manufacturing was kind of a mess because the forecast was wrong. And the reason the forecast was wrong is because marketing people were no good and lazy. If we fast forward to now, 30 years later, the situation is still pretty much the same. If you talk with anybody, any manufacturing company, one of the issues they'll always highlight is that the forecast is always wrong, and that tees up the question that now that we accept that we can put basically any amount of resources into the forecasting process, the forecast is inevitably not what happens in the future. And so the question that we tee up here, and the question that our Gojii product that's based on AnyLogic simulation answers is, if demand's uncertain, how much material should we build? In other words, what are we going to do given that we don't trust the inputs to the system? So this is kind of our existing as-is case. Today, the answer is still that we are going to use a forecasting-based approach. That's the way everybody uses the system. So when I map the existing manufacturing system, I say on the right-hand side of this chart, yeah, it's your right too. On the right-hand side of this chart, we have all these operations and operations tool sets, the operations of the business, and those are something I call those efficiency tools. We get more and more efficient about running this. But still, they all rely on a demand input that we call a forecast. Conceptually, we've not moved past this idea that we have to forecast accurately. And the forecasting process hasn't really changed much, at least in its broad outlines. We have a set of inputs to the process, these scenarios of the future, and the marketing guy thinks it's always up and to the right. So the marketing guys always think this, and the sales guys. And then the operations, CFOs, guys like that, they always think that they're very conservative. They always think that things are going to get worse. We're on the cusp of a collapse is always the concern. And there's lots of other inputs that people have about what the future might be. Some of these might be naive forecasts. Some of these may be some sophisticated forecast tools. But in any case, all that's fed into some negotiation process where ultimately somebody jams numbers into a spreadsheet. That's just ultimately where it all ends up. And that is sort of a politicized process. And so this is the space that we try and position our solution. Now, the selection of that forecast has become politicized, and a lot of the dominant thought process that goes into selecting, quote, the forecast is to minimize inventory costs because that minimizes the risk that we're going to see on our financial statements. So inventory costs are these directly visible, highly tangible, and frankly quite predictable things that we see. And as we build more and more material, as we move from left to right on this scale, then we're increasing the risk that we're going to take with these inventory costs. But there's another factor, of course, and that's the opportunity cost. And these are the costs that are highly uncertain about well, what's the impact of lost sales? Not just lost sales in the immediate period, but lost sales over future time periods where we lose market power, we lose share, we lose supply chain power. We have a lot of effects that could be very significant over long time periods. And this information is basically ignored because it's not tangible. It doesn't appear on a financial statement in any direct way. And the estimates that get done about the value of that are typically highly unrealistic. They're either wildly optimistic or wildly pessimistic. So trying to answer this question about how much inventory or how much material to build, it's not just inventory, it's how we load the line, how we position the material. To answer that question, you really have to understand the shape of this cost curve, and it's a very complex, nonlinear curve that changes with time. It's dynamic. So the actual shape of the curve is a function of decisions we've already made and the emerging marketplace. So our solution, our Gojii tool, fits into this policy space and replaces the ad hoc process with something that's a fact-based, quantitative, structured approach to making that decision. And we have a concept about what best actually means. Best means that we are positioning ourselves to take advantage of upsides while protecting ourselves against unrealistic or inappropriate downside risks. So the context that we make this decision in, then, or take into account, is a feedback context. So the Gojii tool basically is built around a system simulation model. That model includes information about the supply physics, and these capture a lot of the structural things that we hear a lot about that AnyLogic is commonly used for, as well as a lot of what I call the inventory control dynamics, which is to say the decision-making that goes around how the system responds to forecast miss, because the forecast is going to miss. And so what we need to know is what that response system looks like. So we model all of that, but we also model the market physics, and specifically things about how demand may perish or customers may switch. And the specifics of that are going to be unique to the vertical market that we're in, but those impacts are basically going to drive the opportunity cost side of the overall cost equation. And so this tool drives, basically can calculate that cost curve. The overall system structure is somewhat different maybe than a lot of the way people are using AnyLogic. The Gojii simulation tool is the simulator. The inputs to that include the market scenarios, and it's the entire range of market scenarios. So instead of having to select a point of view, a single point of view, about what the future looks like, you can select basically as many as you'd like. And then the set of alternative supply policies, each one of those is a policy that we may choose. So the outcome of this, we're going to choose one of those supply policies. And those would include things about build rate, line loading, safety stock, and so forth. So we feed those into the simulator, and the simulator does a simulation for every pairing. So if we have 10 scenarios, 10 policies, we're going to run 100 simulations, and we're going to tuck all the results into a database. And so that captures all of the simulated cash flows and the simulated material flows. All the specifics of each one of those scenarios is captured in the database. So we have this database, and then we operate on that outcome with a visualization tool to help the stakeholders select the policy that makes the most sense for them. So the implementation, the overall implementation is cloud-based, so in the sense that we're serving it off of a server. The end client is imagined to be companies that are making these decisions on a weekly, monthly, quarterly basis, on an ongoing basis. And the access to the tools is entirely through a browser. So what I thought I would do is show you what these inputs look like, very quickly run a demo, and talk about how we do that policy selection process. So the scenario data, this is an example set of scenario data. Here are two scenarios. Lose my marker here. And so we have time series data. This happens to be basically in weeks. So we have 3 years of weeks. We have the market size, share assumption, units, selling price, and that's one scenario. We have a second, same structure, in this particular case, a different share assumption. So you can build as many of these as you want, taking into account factors about potential competitor actions, pricing changes, all of these sorts of things that could be incorporated and generate a set of scenarios. And then this would be example supply plan data. So in this case, there's 2 supply plans. Once again, time series data, planned build units, standard cost, safety stock, pretty much the basic information. So when I show this to my clients, they say, we have all of this information, and we're using all this, well, and we are trying to use all this information, but we're throwing away the market scenario data in the forecasting process. So with that, let's quickly try and run a demonstration. So I am actually logged into our server, or I'm going to be logging into our server via a hotspot Wi-Fi. And we can just do this. Let's see if I can remember the password. And through some miracle, we actually are able to access the server. These are analyses that we have already run. But what we want, and we can do a variety of things here, but what we really want to do is run a new analysis. So let's hit create a new analysis. And let's just call it demo for AnyLogic. We just navigate to an Excel spreadsheet that has the inputs. And the way the tool works, it's going to upload that off of this client that I'm running. It checks it, just parses the spreadsheet to make sure that the data is correct. Very good. And then it is going to run a simulation for every set of scenarios. I think in the input case, we're going to run about 50 simulations. The simulations are running in a compute cloud. So the size of the cloud simply scales to the amount of processing that we have to do. There's no practical limit to the numbers of scenarios. And then finally, the system is going to visualize those results. So at this point, all the simulations have been run. They're tucked into a SQL database on the server, and we're using a tool called Tableau. I'm sure many of you are familiar with it. Tableau is a commercial data visualization tool, and we are using a served version of that. And at this point, what we're waiting for is for Tableau to actually visualize that data so that we can access it through the browser tab. While we're waiting, and that'll take just another minute or two, you can see the visualization part of it takes a lot longer because of Tableau than the AnyLogic simulation. Now, I want to switch back to the presentation for a moment and talk about how we evaluate results. Because now we have all these simulation results. We have a lot of data. But the people who make decisions, typically in this case would be general managers, vice presidents of marketing, vice presidents of operations, stuff like this. They do not want to look at in general, don't want to look at simulation results in too much detail. And so through our interactions basically with them, they have guided us to a decision chart, and I want to tell you about that. So the way that we look at the results is that we rank order every policy alternative by increasing investment. So as we move from left to right on this chart, every bar involves increasing the amount of capital that we are going to invest. And we're going to map that against what I call profit risk. And by profit risk, I mean how much profit are we putting at risk if I choose a particular alternative. And the height of the bar reflects the range of risk. Because the future market conditions are uncertain, then there often is no single answer. There's a range of possible answers. And so this involves, how much risk are we going to take given a range of future outcomes. So in this particular example, and this data is conceptual, but it does reflect the shape that we see in a lot of our actual results. As we move from left to right, as we spend more money, as we take more direct inventory cost risk, then the opportunity cost risk is decreasing. And as we get into some range out here in the middle, then these start to look like good alternatives if I were a decision maker. Because in those, I have a low profit risk if things go badly. If things go the other way, I still have a relatively low risk. And I don't have to overspend. You'll notice that as I move all the way to the right, then I have excess direct cost. I'm actually overspending to protect against the perceived risk. So the actual result, which I believe should be available, and it is, the actual result has a lot more detail complexity than the chart that I just showed you. And so this chart is a Tableau visualization of the data set that we get. If you view, we have nowhere close to enough time to explore how Tableau works, but the way to read this is each one of these columns is like the solid columns we saw on the PowerPoint slide, and each mark reflects one of the market scenarios. So in this example I ran, we had 5 market scenarios, and we had, looks like nine possible policies. And so as I move from left to right here, you can see that the profit impact is going to change. And we can hover over any of these to understand how much. In this case, it says if in the market scenario of high 2, and if I choose a low build policy, then I'm putting $18.5 million of profit at risk over a time frame that's set by these sliders. Now, one of the advantages of pairing the visualization with the simulation here is that we can explore this data sort of interactively. So one of the concepts here is there's certainly some costs associated with inventory, which were set at 10%. I can just change that. Because, whenever I talk with my customers, they always say, oh, we know all these things. Then I'll ask them, so how do you think about your cost of capital? Well, I get maybe 3 or 4 different answers. So in reality, what we're supporting here is a collaborative exploration process. So as the different points of view, the different stakeholders in the company have different inputs, we can just try it in real time. So here I increased the cost of capital, which had basically no policy impact at all. So if I look at this, I see that maybe I should select select something like this as my outcome. It depends, what the client actually picks often depends on how much capital they actually have. So part of this is answering the question that if I can't protect against all of the risk that I want to, how much risk am I taking? And it reports that result as dollar-denominated profit, which is a very bottom line sort of measure. Now we can do one more thing, which is, and I'm going to switch to because our internet link is a little slow, I'm going to switch to a local version of that same chart. And what we can do is we can change the window at which we look at things. So here, if I looked at this particular business, it has the same conceptual chart. It seems like it makes sense. But what happens if I look at it not over a 1-year period starting 18 weeks from now, But what if I look at a 1 year period, or maybe a 1.5 year period? So if I do this, the shape of this curve changes dramatically. So I find that there's this cliff that if I were to choose this low build policy, which was previously one of the safest policies, it becomes one of the worst. And the reason is because as we look at the results over longer time frames, then the impact of our decisions today become, at least in this business, can become more and more dominant. And so one of the big, I think, takeaways for our clients was they need to think about this over a lot longer time frame. It's not just how much business are we going to lose next month or next quarter. It's what's the impact of these decisions going to be over the next 18 months. So one final slide to finish up. Example use cases. The most common use case, the one I really presented here today, was really to on an ongoing basis, just set inventory and build rates by product line. I found, as we use this with clients, I found one thing that's almost universal. Companies appear to have the same inventory policy or build policies for maybe all of their product lines or a wide range of product lines. When we started using this tool, we discovered that different product lines have radically different results, and that by looking at each product line individually, you could get tremendous leverage. So that's kind of the base case. Very useful if you're in a business that has to commit order lead time or commit buffer sizes to your customers. A lot of this work was done for electronics manufacturers. They often have to guarantee certain buffers and lead times, and they can never answer the question, how much does that cost? And this is the only approach, because the cost is based on the amount of risk or a repositioning of product lines. So that finishes my prepared notes, and I'm ready for questions.